Hi there, this is Jacob Nash, Precalculus Lessons. And this is Unit 1, Lesson 10 on inverse functions. Extended intro today. Still the same song. So there you go. Inverse functions. Oh, you might say, once again, something that you already know. Or you might say, I think I used to know that, but I forgot what it was. Okay, well, either way. Or you might not even remember it. But either way, still, I'll show you what it is. So, inverse functions have x and y values switched. So, they're basically the opposites of each other. That's what inverse means. So, example includes, if we look at our quadratic function, it looks like that. And then we have our square root function that looks like, it looks like that, but technically, in some cases, it could look like that. I won't explain that in this video, but so that's basically what inverses are. They always have symmetry over the y equals x line, and they have x and y values switched. So if 1, 2 was a point for the red one, then the blue one would have 2, 1 as a point. So that's what it's always like. So the points that they have are switched. If you want to find out if two functions are inverses, switch the x and y. You can, I thought that this thing said or. It used to, at least. But, those three things, that's not steps. That's just different ways you can do it. And the one that's the easiest to do is number 3. Number 1's not that bad. Number 2 is stupid to me, but sometimes that's what you can do too. But you can switch the x and y values. You can use the composite function. When you do the composite function, you should get x's value. But why I think it's stupid is because it takes too long and it's pointless when you could get your answer faster. Or number 3 you can get right away by using the one. Yeah, I'll explain it because I'll do all 3 methods. So there's only 2 problems, and the first one we're going to use these 3 things. The second one we'll do something different, but we'll see. So are the following inverses? I already can tell you that they are, but let's just make sure. So this is a cubic function, and it happens to be the parent function, and this is the cube root. The only reason why it's something as simple as this, which, by the way, you'll probably get more complicated things like that. I just did that so that I could be sure that the answer would be something that was inverse. So the first thing we can do is we can switch x and y. So f of x and g of x really are y. So let's start out with f of x. If we switch x and y, okay, let's switch it. So now we have x equals y cubed. But we want y to, when we ever have our parent functions, we always have to have y by itself. How we can do that is if we take the cube root on both sides. So we get y equals cube root of x. And this is our inverse function. And that happens to be what this is. So that's one way we can know that it's inverse. We could also switch to x and y for the g of x. Oh, sorry. It's about to write the same thing. Now we can cube both sides to get y by itself, and y equals x cubed. So that's one way we can do it. So that's one way. Now I'll show another way in green. Composite function. So what we need to do is do f of g of x and g of f of x. And we must get x as our answer when we do that. But this is the one that I said was stupid because it takes a long time when you have something dumb. This time it wouldn't take that long. So let's start with f of g of x. So we put g into the x of f. So this is g, and we put it in the x spot for f. F is x squared, or x cubed. So x, we change that to this, and then we still have cubed. We know that with that those would cancel out and you would get x. So that we know that possibly we could have inverse functions, but you have to see both to make sure it's true. Now we put this into the x spot for a g of f of x. So we have the cube root of x changes to x cubed. Once again, we get x as our answer. So that is the second way to know that they're inverses. By looking at that. That's how you can tell. Because you get x as the answer. The third way, to me, is the easiest. You can take any point and let's just use 1, and let's look at what happens when x is 1 for f of x. So, this is f of x. We're figuring out what happens when x is 1. So how do we figure that out? We put 1 into the x spot. So x cubed, so we do 1 cubed is 1. Oh, that's not a good example. You don't have to use 1 every time, but the reason why that's not a good example is because we got 1 and 1. Let's just try 3. So this time let's plug 3 into there. 3 cubed is 27. So how we can know if they're inverses is if what y value we just got, which was 27, our answer when we plug that into this should be 3 if these are inverse functions. So cube root of 27 is 3. So that's another way you can know these are inverse functions. So those are your 3 ways to do it. Most teachers teach that way, the green way. And the purple way isn't even really like a proper thing to do because it's just kind of random. But what you do basically, as I showed you, you just take any random x value you want, plug that into the function, and whatever answer you get, plug that into the next one and see if you got the same thing as the original one number that you picked, because the x and y values switched. So 3, 27, 27, 3. So there you go. We could take another example. I'll make up functions and let's just say f of x is 2x minus 4 and g of x is 4x divided by 3. Okay, let's see if these are inverses. The blue way, switch x and y. So this is y, remember? So, and I'll show you what that would end up being. So we don't even need to do anything else because this is not the same thing as that. So we know these aren't inverses. How we can see that with the green way, I'm not going to do that this time, but what you would do is do f of g of x and g of f of x. Let's do the purple way. Let's just think of a random point. How about 3 again? Let's plug 3 into this x. 2 times 3, 6, minus 4, 2. Alright, now let's plug 2 into this and see if we get 3. 4 times 2 is 8. 8 divided by 3 is 8/3. And that is not 3. So no. And actually, when you're doing this method, occasionally you might want to try 2 points to make sure, because there might be some rare coincidence where it happens to be the case for one of them, but not all of them. So there you go. That is that. Now, what if you have to find the inverse of it? Well, like I said, you just switch x and y. So this equation is y equals 2x squared plus 4x minus 1. And we know that, what was I trying to say? We know this is like the blue method. So we switch x and y, 2y squared plus 4y minus 1. Now, this one's a little bit tricky because we have 2 y's. That's not usually going to be the case. So let's just change this. Let's pretend that this term doesn't exist. So it's just 2x squared minus 1. Okay. So now we add 1 We're trying to get y by itself, remember? Divide by 2. Now, take the square root. So y equals the square root of x plus 1 divided by 2. And by that, we could tell that our original thing was quadratic, and our new thing is a radical. Although it has a fraction, so you might think, oh, would that mean that it's the reciprocal function? No, because this would end up just being 1/2 x plus 1/2. So, no. But there you go. That is inverse functions as a review. So, thank you for watching, and I'll see you on the next video.